Hello students, welcome to today's session. Today we are going to discuss the practical number 10 for the subject computer science class 12. So we have already discussed the 9 practicals in this series. If you didn't watch these practicals, I will strongly recommend to please go and watch these practicals, because these practicals have covered the major concepts like file handling and your natural recursion. All those practicals are done. So today we are going to discuss the new practical series, new practicals that are implementation of data structures using the list. So today we are going to solve the very interesting problem. So first, as usual, what we are going to discuss, we are going to discuss the problem first, then we are going to discuss the steps to solve it, okay, and then we are going to write down the Python code, and then we are going to run the code in Spider editor. Okay, I am using the Spider editor. If you are using any other editor like Sublime, Jupyter, or any editor ideally, or so Python default ideally if you are using, it will work also in that IDEs and demonstrate it. Okay, so let's try to start the problem first, and without any delay. So today is an interesting problem. Implement the stack data structure using the Python list data structure. We have already default data structure of the Python. We are going to use this data structure and we need to implement the stack. So before starting this practical, if you don't know what is stack, I am going to tell you in detail what is the stack. Then only you will be able to implement the stack data structure. First we are going to discuss about the stack, and then I will give you what is the list, and then we are going to implement the stack. What is the stack? Stack is a data structure. It is a data structure that works on the principle of last in and first out. That means LIFO. If you have attended the theory class, you might have know this. So last in first out means the element which is inserted at the last time. Let's suppose this is the stack. If you insert the element, let's suppose you are inserting element, let's suppose 15, then this will become the top. Then if you are inserting again any element, other element, let's say you are inserted 20, then again the top will become this one. This top will be destroyed and our top will be this 20. Again if you have inserted another element, let's suppose 35 you have inserted, then your top will become this element. This element will not become top. Now top where is the pointer that will point always to the topmost position on the stack. Let's suppose this stack has the size of the stack is, let's suppose 5. It is the capacity of the stack, that is maximum size that it can hold is the 5 elements it can hold. Let's suppose this stack has the 5 is the maximum capacity, and if you are keep on inserting, the value which we are going to insert into the stack is known as push operation. Push is what? Inserting the value or element, let's say value or element in the stack. This is known as push operation. Okay, so we are pushing the 15. We are first pushing the 15, then we are pushing 20, then we are pushing 35, then let's suppose we are pushing the 10 value, and then what will happen? If you insert 10 here, then 10 will come here, and your new top will point this. Now this top will not point to 35. Now your top will point this if you are pushed the 10. Now let's suppose push again one more element. Let's suppose you want to push, and that is your, let's suppose 5 you want to push. Then your 5 value will become here, and your top will change, and your top will point to here. Now if you try to insert one more value, let's suppose 12 here, then it will not insert. Because the stack size is 5, we are going to implement any stack that has the limitation of the size because stack has a limited capacity to store elements. So we will, let's suppose our stack has the capacity to store 5 elements, then what will happen, it will have hold the values, we can insert 5 values in this stack. After that, if you try to insert 12, if you try to insert 12, then it will give error, message showing stack overflow. Stack overflow is what, if we have inserted the elements in the stack up to its capacity, and if you are trying to insert the next element after the stack is full, then this condition is known as stack overflow. What is stack overflow? If our stack is full, let's suppose our stack capacity is 5 and you have inserted 5 elements in this stack and your top is pointing to this 5, then if you are trying to insert a new value in this stack, then if the stack is full, then if you are trying to insert the element into the stack, then this condition will be known as stack overflow. We cannot accommodate this 12 into this stack because its size limitation is about 5. Okay, so this is how this stack works. Now let's suppose this is the push operation. Inserting the element into the stack is known as push operation. But in case of stack is the last in first out. The element that we have inserted at the last will pop first, will remove first. Let's suppose you want to pop. Pop is what? Removing the last element from the stack, removing the last inserted, you can say inserted, because the element that is inserted at the last will be removed first. Removing the last inserted element from the stack is known as pop. Let's suppose if you want to do the pop from here, let's suppose if you are removing this 5 from the stack, then this 5 will be removed. In that case, this space will be free and your top will again point at what position? Your top will point to this 10 now. This top will point to this 10 value now because 5 is removed. If you call again pop, if you again call pop method, let's suppose you call this pop method first time, and if you again call pop method, then it will remove the last element. Last element is what? At this time 10 is the last element, so this 10 will be removed. 10 will be removed from here. Now your top will point to which value? Now your top will point to this 35. Now if you call again pop method, then your 35 will also get deleted and your new top will become what? Your top will point to this 20. At this time, if you want to insert new element, you can push any element if your stack has the memory capacity. Let's suppose now the stack has the 2 elements only, these 2 elements. Now you can insert into top. Now you can also insert, let's suppose you want to insert 12 here, then this 12 will be inserted at this location. At this location 12 will be inserted and your top will point to this location 12 after removing this top from this cell. So you can push the element. The thing is that you can push the element in the stack, okay, till we get the maximum, till the stack is not full. If stack is full, if stack's limitation is 5, if the stack capacity is that your stack can hold 5 values, then your stack will be full after inserting 5 values. If you delete 2 values, then you can add more 2 values here, but condition is that these elements will be inserted at the top of the stack because 15 is the first element. This element will be removed at the last if you are going to pop. So if you are going to pop 5 times, then you are going to get this element what? 15 removed. And let's suppose you are keep on removing the elements from the stack. If you are keep on removing the element from the stack, and if your stack is, let's suppose this is also in one condition, if your stack doesn't contain any element, if your stack doesn't contain any element, if your stack doesn't contain any element, and if you try to pop, then this condition is known as stack underflow. Stack underflow. What is stack underflow? If you are removing the element, keep on removing the element, and you are reached at the point that the stack is not having any element, then if you are trying again removing the element from the stack, then this condition is known as stack underflow, and you should show the error message to the user that stack is underflow. Okay, so you understood the stack. What is stack? Stack is a data structure that works on the principle of last in first out. The element that is inserted at the last will be removed first. You see, 5 is the element that inserted last, so 5 will be removed first if you call the pop method. Again you call the pop method, 10 will be removed. Again call the pop method, 12 will be removed. Again call the method, 20 will be removed. Again call the method pop, 15 will be removed. So 15 is the value that we have inserted the first position, but it is removing at the last, because this is a stack. Stack is the data structure that work on the concept of last in first out. The element that is inserted at the last will be removed first. Keep this in mind, and you can implement this stack. There should be, you should know push operation, pop operation, stack overflow, and stack underflow condition. If you know that much about stack, then we can go ahead and implement the stack using list. So if you know the push is basically to insert the element into the stack at the last position. Pop is the operation that removes the element from the top of the stack. Stack overflow means if your stack has the capacity, if your stack is full up to its capacity, and if you are trying to insert one more element into this stack, then this is known as stack overflow, means your stack is already full. If you try to insert any element in the stack, that condition is known as stack overflow. What is stack underflow? If you are keep on deleting the item from the stack, and you have removed all the items from the stack, and there is no element left in the stack to delete, in this case this is known as the condition stack underflow. And what is the top? Top is the value that is the last inserted value is known as top. What is top? Top is the value that is last inserted into the stack, okay. So this is known as stack data structure. Now what we are going to do, we are going to implement this stack using list. So for that purpose I am going to tell you some important methods that we are going to use to implement this stack using list data structure. So let's try to rub some portion and try to implement this. Let's try to delete everything and try to get some idea about list. What is list? List is a collection or sequence of any data type, okay. लिस्ट के अंदर आप कोई भी डेटा टाइप का डेटा रख सकते हो. It is a collection or sequence of any data type. So what we are going to do essentially, this is the list. Let's suppose you are creating some stack variable, that will be essentially a list variable, and if you want to insert into this stack, that means push operation. If you want to push into the stack, what we are going to use, which method we are going to use? We are going to use the stack dot append method. Append method of the Python list is basically used to insert any item into the list at the last, okay. So this is the append method. You should know what is the what method we are going to. Let's suppose you are calling this stack dot append 1, and what will happen? This variable will become like 1. If you are again call stack dot append let's say 10, then this variable become 1 comma 10, and this is the top value that is last inserted. Logically we are pointing it. Let's suppose you are trying to insert one more value append, and let's say 5, then this 5 will be inserted, 1, 10, 5 will be inserted at the top. So this is how append method will help you to implement the push operation. We are going to use the append method to insert the element into the stack. Before inserting the element, we need to check whether what is the capacity of the stack. For checking the capacity, let's suppose maximum limit I am going to define. Let's suppose maximum limit I have told that 5 element is the capacity of the stack. Then before inserting the item into the stack, what we are going to check? We are going to check the length of this stack. If length of this stack is equals to maximum limit means if you have inserted the items, 5 items you have already inserted, in that case length of the list, length of the stack is basically list. So we are going to list data structure, that's why this is a list. So length of the stack is, let's suppose if 5, that means 5 equals to maximum limit is also 5, that means stack is, that means we are going to print stack overflow, that means stack is overflow, because logically we are creating some limit of the stack, because stack is the special kind of data structure that has the limited capacity. So we have given this limited capacity, let's suppose 5 elements. So up to 5 elements we can call this append method. If you are calling the append method, let's suppose append 10, then 10 will be inserted again, 1, 10, 5, then 10. If you are one more time, if you are call append method and insert 100, then this 100 will be inserted, 1, 10, 5 and 10 and then 100. Now again if you call the append method, let's say 12, this time you should not insert it because the list has the capacity of the 5 or the stack has the capacity of 5. We have already inserted 1, 2, 3, 4, 5 values, then your condition will run length of the stack equals to maximum limit. It is true, so we are not going to insert this element into this list, and we will show the error user message, show the error message to user, that is stack is overflow. So we are going to essentially implement this push operation using that much condition. So what we are going to write the Python code for implementing the push operation on the stack. We are going to do what there, let's see here. So I am going to write here, so that push operation, let's suppose push operation I am implementing, then what I am going to write, I am going to write this, if first I am going to check the condition length of the stack. If the length of the stack, then I will combine this code whole and maximum limit. If the length of the stack is equals to maximum of the limit, that means our stack has no capacity, and we can say stack is overflow. Stack is overflow. If this condition is not true, that means you can insert the element into the stack. You can simply call stack dot append method and pass the value that user has entered. This is the push operation implementation of the stack using list. So this is the push operation. Now let's try to implement the pop operation. Okay, so I am removing this much and try to implement the pop operation. What is pop operation? How we are going to implement the pop operation? Okay, so let's remove this whole thing, and how we are going to implement the pop operation I am going to tell you, because this is the implementation using list we are going to do. So we need to use the list methods for implementing the stack here. So stack, now we are going to implement the pop operation. So for pop operation, let's say POP. Okay, pop operation we are going to implement. So what is the meaning of the pop? Pop means removing. So let's suppose this is our stack currently. Let's suppose we have inserted 5 elements in the stack using append method, and our top is the value that is pointing here. Top is the value here pointing. Let's suppose you call the what is the method of the list to remove the element from the list from the last. We are going to use the pop method of the list. List method, pop method. List pop method is basically used to remove the item from the end of the list. So what we are going to do? We are going to do the, let's suppose, pop method. So what we are going to do is stack dot pop. Stack dot pop, if you do, then it will remove the last element of the list. Last element of the list is what? 100. So this 100 will be deleted. Our list will become like this, and our top will point to here. So if one time if you call the pop method, this stack will become like this. Again, if you call the stack.pop method, again the last element of the list is what? This time 10. So this 10 will be removed and your stack will become like this. So we are removing the, and again if you call the stack.pop method, then again this, now currently top is 5, so this 5 will be removed and our stack will have the 2 elements. Now your top is 10. If you are again calling the stack.pop method, then this time what will happen, this 10 will be removed and your stack will have the only one element. Okay, this is the one element left. Now if you call the stack.pop again, then what will happen, this one also get deleted, this one also get deleted, and your list will become empty. And if you again call the stack.pop method, now if there is no element left in this stack, or you are calling the pop method again, then we should give the error message to user that list or stack is underflow. So how you will give this error? If length of the stack is equals to 0, then if you are trying to call the pop method, then we will print the error message stack underflow. So this is the basic method that we are going to use, because after removing each element from the stack, your length function will return 0 for this condition, and if your stack length is 0, then we can say that user stack underflow, your stack doesn't have any value. So this is the error message we are trying to do. So let's try to implement the push operation and write the Python code for the push operation here. Okay, so I am writing the push operation code somewhere here, let's suppose. So I am removing this definition and trying to write the pop operation code here. So let's try to create some space. Let's try to write the pop operation code somewhere here. Okay. So what will happen with the pop operation? So let's take some different color and write it. Okay. So before popping element, what we are going to check? Let's suppose we are going to implement the pop operation. So how we are going to do the pop operation? Remember these conditions, because I am going to merge this code again. So if length of the stack, previously we were checking for the maximum limit, we are going to show the error message stack under overflow. Now if the length of the stack is 0, then we will print the error message to user stack underflow. Stack underflow means stack doesn't have any element to delete. Otherwise what we are going to do, we are going to keep on popping from the stack as much as user wants. So this is the implementation of the pop operation using list. So these are the two implementation we have done. Now if you want to print the top element, how can you print the top element? I am going to show you the code. So top element, how can we print? Let's try to see it. So I am removing all those things and I am going to print the top element of the list. Let's suppose user wants to print the top element of the list, then how he is going to use this top element, how he is going to print this top element. Let us suppose your list, let's suppose your stack has this item, let's suppose. So top is the basically logically it is the last element of the value. So how you generally access the top value in the stack or list? Using which method you can use to get the top element? Print the stack and -1. If you do this code, that means your top value is the last value. Top value is what? In the stack is the last value of the list. And if you, how you print the last value in the list? 3, 4, then negative indexing, you know, -1, -2, -3, -4. So -1 is the index for last element. So essentially top is the basically value that is the last element of the stack. So if we print the stack and then pass the -1, then it will be the top value in the stack. So this is how you can print the top element in the stack. And if you want to print all the values in the stack, if you want to print all the values in the stack, so how can you print all the values? All the values in the stack if you want to print, then simply what you can do, you can simply print the list. So if you want to print all the elements of the stack, then you can simply print stack. This will print the all the elements of the stack. So we have already implemented all the methods. I have shown you how to implement the push operation, how to implement the pop operation, how to implement the top operation, how to implement the all values, how to print the all values. So let's try to dry run this and see. So now we are going to use the infinite loop here to show the message to the user. So I am going to remove all those steps and let's try to see this stack working. So let's try to use the while infinite loop to give the user choice to insert the value into the stack, and then we are going to run it. Okay, so we have seen how to implement the push, pop, top and all values operation. Now we are going to run a while loop, that will be the infinite while loop. So while, what we are going to do, while true, what we are going to do, we are going to give user choices. Let's suppose print 1, enter 1 to insert into, to push into stack. So these choices we will give to user, and press enter 2 to pop from stack. We are going to enter 2, let's say, and enter 3 to print top value of stack, and enter 4 to print all values of the stack. Okay, so and enter 5, let's suppose, to quit. Okay, so this is the, let's suppose, Python code we are trying to run. Now if user has entered 1, if, let's suppose, enter the choice, so we are going to enter the choice, integer input, enter your choice. If the choice is 1, we are going to implement this. If the choice, I am going to write the code here, if condition, let's say, if choice equals to 1, then what I am going to do, I am going to write this whole code here. If the choice is 1, then I am going to write this whole code here. If the length of the stack is equal to maximum limit, then I will print stack overflow, otherwise I will append the value. I will ask the user for inserting the value equals to, I will write like this, let's say value, let's write it clearly so that you can get idea. Value equals to integer, or you can insert any value of your choice, enter value to insert, value to push, enter value to push. So this value we are going to essentially pushing using this code. Okay, and elif we are going, if choice is equals to 2, then what we are going to do, we are going to write this much code here in this condition directly. Elif, again this much code we are going to write here. Elif, if choice equals to 3, then what we are going to write this code here directly. Elif again you will write here, let's suppose I am going to write here, the no space, elif, and if you write the choice equals to 4, then what we are going to do, write this code here. Else, if none of the option is there, then break this loop, because this is the infinite loop, you need to break this. So this is the essentially complete code. This code you will write at the top. First you will write this code, then you are going to write this code, and then you are going to write this code as per your location, 4th, 5th and 6th. So this is the complete implementation of the stack. If you can see it, running. We can implement this stack and see it running. Okay, so let's try to get some example. How can you dry run this program? Let's try to dry run this program. Okay, so let's try to, let me show you, let me write this code completely in a one single line, single file, and then we are going to dry run it. Okay, so let's try to rough this and dry run it. Okay, so I am going to write the Python code. I have explained in detail how this implementation will take place. Now I am going to write the Python code and see it working. So let's try to write the Python code from here. So we are have the space. Let's suppose create a stack variable. I am going to create some stack variable here. If this pen is not visible, then let's take the black pen. It has the maximum visibility. So let's try to stack. We have empty stack currently, and maximum capacity or length, whatever you call, maximum capacity is equal to, let's suppose 5 elements we want to insert. You can increase or decrease your capacity as per your requirement. So first we are going to write the while loop, while true, and you are going to give the choice to the user, multiple choice. One, push value in stack. Second, pop value from stack. 3, print top value of stack, and then 4th choice you are going print all values of stack. Okay, and let's say 5 for exit. So this is the essentially we are printing for user information. Now we are going to enter the choice equals to, let's suppose, integer input, enter your choice, user will enter his choice among those. Now if choice equals to 1, then we are going to push. Before pushing the element, we need to check for stack overflow. So if length of the stack equals to maximum capacity of the stack, then what we are going to do, we are going to print the error, print stack overflow. Otherwise what we are going to do, otherwise simply ask for the, let's suppose, value equals to integer input, enter value to insert, enter value to push. So whatever the value you will enter, we are going to append it. Stack dot append method we are going to use of the list and value. So this is the code to insert the or push the value into the stack. Now let's try to write the second choice. If user has entered the 2, then what we are going to do? So if user has entered the 2, then I am going to write this code here. If let's suppose if choice is equals to 2, then what we are going to do, we are going to check for the underflow condition. So if length of the stack equals to 0, in that case what we are going to do, print stack underflow. Otherwise what we will do, we will keep on popping. We will pop using pop method, stack dot pop. Or if you want, you can print this value also, n equals to, and you can print the message n is removed from stack. Like this you can give a pretty good message here. And if the user has entered some other choice, let's say if user has entered elif, you can use here elif condition, you can use elif. And if user has entered some other choice, let's say elif choice equals to let's say 3, then what we need to print the top element. So simply you can print top of stack is what? Stack minus 1. Negative indexing, using negative indexing you can access the last element. And now next condition, elif choice equals to what? 4, then what you can do, print the complete stack, then print the stack values. So all the values we are printing. Otherwise if user has entered any other choice 5, 6, 7, that means we are going to exit from the loop. Okay, then we are going to exit from the loop. Okay, so you can exit from the loop using this line. Let's say write it using this line. So else we are going to, we need not to do anything, we need to break this actually infinite loop. We are breaking this infinite loop, then this program will terminate. Okay, so this is how this whole implementation will work. So this is the complete program for implementation of stack using list data structure. Okay, so let's try to dry run this and execute. Okay, so let's try to dry run. I am dry running it, and let's suppose you are running this code. Then what will happen? First this message will be printed, and let's suppose user has entered the choice, let's suppose 1. You entered the choice 1, then this condition, length of stack is what? Initially length of stack is what? 0. 0 equals to maximum capacity 5, condition false. Then what you can do, you can insert the value. This code will be entered, value will be asked from the user. Let's suppose user has entered the value 10, let's suppose. Then this 10 will be appended into this stack. So this is the stack, let's suppose this is the stack you are implementing, let's suppose. So 10 will be, this is the capacity of the stack is 5 elements, so 5 element capacity. So 10 will be inserted into the stack and your top will be there. Okay, now let's suppose again this is infinite loop. So again user be asked for the choice. Let's suppose again you have insert the choice 1, then again user will ask to enter the value. Let's suppose this time you have entered the 5, then this condition will be checked. 1, length of the stack is 1 because 1 element is there. 1 equals to 5, condition false. Again this user will ask the value to enter. Let's suppose you have entered the 5, so this will be inserted into the element at this position. So your top will now point this position. Okay, this point to this position. Now let's suppose user, this is infinite loop, again you will execute. Let's suppose you are keep on inserting 1, and then again this condition will be checked. Now this time length of the stack is 2, 2 equals to 5, condition is false. Again this loop will ask, this condition will false, again this will ask for value. Let's suppose this time you will enter 12, and this 12 will be inserted into this stack and your top will point to this position. Okay, top is the ideal pointer, I am not using top anyway, but this is the way that a stack is actually shown. Okay, now let's suppose user has entered again one choice because this is infinite loop. Let's suppose this time the length of stack is what? 3 element is already there. 3 is equals to 5, condition false. Again you can insert into this stack. Let's suppose you are inserting this stack, this time let's suppose 60, then this value will be inserted at this position 60. Your top will point 60 now. Now let's suppose again you have entered choice 1, and again this condition will be checked. 4 equals to 5, condition is false. Again this is false. Now again user will be asked to enter the value. This time let's suppose you have entered 2, this enter will be here and your top will be this position, this top position will be this. And again if you are entered the choice 1, and this time your length will become 5, 5 equals to 5, condition is equals to true. That means this error message will be printed, stack overflow. So this time you will get the message stack overflow because your stack capacity is what? 5 and your stack is full now. So this is how this program will, now this is infinite loop. User will ask the choice again. Let's suppose this time user has entered the choice 2, this time again choice is entered 2, then this code will execute. Else if condition, length of the stack is what? 5, length of the stack is what? 5, 5 equals to 0 or not, condition is false. You can remove, so the top value, last value from the list will be removed. Your top will point this position. Next time again if user has entered 2, this line will executed. 4 is the length of the stack because one value is deleted. 4 equals to 0, condition again is false. This time pop will execute and this 60 will be removed. Your top will point now this 12 position. Again if you want to, let's suppose in between user has entered the choice 3, then what will be the top of the stack? Top of the stack is stack minus 1. Stack minus 1 will be the 12. So the 12 will be printed on the screen. If you want to print the choice 3, then stack minus 1 will be this value because top two values already removed, so this element is the top value. So this is how you can print the top value. If user has entered the choice 4, then all the elements of the stack will be printed. That will be 10, 5 and 12. This way it will print the values of the stack if you enter the choice. Let's suppose a user has again entered the choice 2. Because this is infinite, you can keep on entering the choice 2, and this time length of the stack is what? 3 equals to 0, condition false. This element will also remove, the top will point to this position. If you are entered again the 2, then this length of the stack will be 2 equals to 0, condition again false. This value will be deleted from the stack and your top will point to this position 10. This time if your user has entered the choice 3, then top element will be printed as 10. If user has entered the choice 4, then list will be printed as 10. And if user has entered the choice 2 again this time, then this length of the stack is 1 equals to 0, condition is false. You can delete one more element and this 10 will be deleted and your stack will be empty now. Again if you are entered the 2, then this length of the stack will be checked. Length of the stack is 0 equals to 0, condition is true. This time the message stack underflow will be printed. So this time stack underflow will be printed. So this is how this stack implementation is working. Okay, you got the idea. Now we are going to write this code into the Spider editor and run this code and see how it is going to work. Okay, so this is the important step. If you didn't got the idea, please re-watch this video, you will get the idea. So let's try to go into the editor and run it. Okay, so I am going to the Python editor now and implement this. So first what we are going to do, we are going to write the stack method. So stack I am creating, stack is equal to blank list, and maximum capacity I am giving to this stack. Let's suppose you can give any capacity. Let's suppose 10 is the capacity I am giving. You can give 100, 200, or you can give any of as per your choice. Now we are going to write the while loop, true, infinite loop, and we are going to print a screen message to user. And this time I am going to use the multi-line string so that you can and show your choices in one line. And push value into stack. Okay, and then enter and run this. And this screen multi-line string I am using, that's why. So I am going to write this here, 2 dot I am going to write pop operation, pop value from stack, and if you want to, the user has entered 3, let's try to write this. This is a multi-line string, it can be here also 3. And if you want to print top value of stack, you can use this line. For to print all values of stack, you can use enter 4 and any other number to exit. Okay, let's try to write this. Now I am going to do what I am going to do. I am going to ask the choice from the user. So I am creating choice variable, integer input, enter your choice. So I am going to ask the enter your choice. Now if this choice is 1, I am going to use if choice. I am going to use the if condition. If choice equals to 1, what I am going to do, I am pushing the push operation I am going to do. So this way I am going to check if condition for overflow, length of the stack equals to maximum capacity, then what I am going to do, print the stack overflow. In that case you should remove some element, stack overflow, and else I can append. So for that I need to ask the value from the user to insert into the stack integer value. Let's suppose you can ask any value, but for now I am going to insert, because list is the data structure that can contain any value, that's why you can ask any value. Enter number to insert, push into stack, push into stack. Okay, so this way you can show. Okay, so user will enter and you will simply append this value into the stack using append method of the list, and you will pass this value here. So this is the code for choice 1. Let's suppose if user has entered choice equals to 2, in that case what we need to do, pop. Before pop we need to check for underflow. If length of the stack is equals to 0, 0 means the stack is empty and then there is nothing to delete, so you can say print stack underflow. Okay, you can show this error message. And else if stack has some element, then you can directly pop stack dot pop method you can use, pop, and you can hold the value that is pop method returns the value that is removed. You can print for better user experience, print and removed from stack, like this you can say. And if else if user has entered the some choice, let's suppose 3, then what you can show, if user has entered the choice 3, then what you can do, you can simply print the top of the element. So top of the element is what? Top is what? Stack negative indexing used and -1 will be the top element. Print top of the stack. Top of stack is what? Is this number, that is top. And else if user has entered choice 4, choice equals to 4, then you can see all the elements of the stack. Print the stack, simply print the stack, or you can say the message here, all elements of stack, all elements of stack are. This way you can show. And if entered any other choice, then you are going to break this loop. That's all for this program. So now let's try to run this and see. Capacity is 10. Let's try to reduce the capacity for testing purpose to 3, so that you can get the clear idea. So now I am running this. If you want to note this program, I am scrolling it little bit slowly, so that you can note it into your notebook, or pause the, or take the screenshot line by line. You can take the screenshot by pausing this video. I am slowly scrolling it, because this is a big note fitting in a one page. Now I am going to run. Okay, so if you run this, so here, see here, push value into the stack. So 1 pop, 2 for pop, 3 for printing the top value, 4 for print all the values in the stack. Let's suppose enter other number to exit. So let's try to enter the first to insert into the stack. So let's suppose you are entering the choice 1, enter number to push into the stack. Let's suppose I am entering 10. Let's suppose again I am entering the choice, because this is a infinite loop, so again this is asking choice. Let's suppose I enter the choice 1 again and insert the number to push into this stack. Let's suppose I am inserting 12, and let's suppose again I am going to insert, let's suppose press 1 and enter the choice, let's suppose insert 3. And if this means, let's suppose print all the elements of the stack, it is printing 10, 12, 13, that means 10 is first inserted, 12 is again inserted, and 3 is the last inserted. If you want to print the top element, just press the 3, it will print the top value is 3. Therefore top value is 3 here. Now if you want to again insert one more value, it should give the error, because our stack capacity is 3 element only, because we have specified 3 as the capacity, so it should consider this. Let's try to insert one more value into the stack. Let's suppose if you are trying to insert, it is giving that stack overflow. The stack is already reached full and it has the 3 capacity, so it is giving the error. Now you can delete some elements. Let's try to delete some element. Let's try to pop some element. Enter the choice 2, then enter the choice 2, then 3 is removed from the stack, because 3 was the top value. Let's try to print the top value. You can print the top value by pressing 3. This is showing that top value of the stack is now 12, because the 3 is removed. You can print all the values by pressing 4. This way you see that 3 was removed. Now let's suppose remove one more value. Let's enter 2. Now this one time 12 is removed. Now if you print the top value, it will print the 10, and if you print the all the values, it will show only 10 value, because 12 is also removed, because we have two times we have popped the value. Let's try to again pop value. Now in between you can also insert some value. Let's try to insert some value again. Let's suppose you insert 55. Again the top value will become now 50, because we have inserted it again. So this time 50 is inserted, and if you want to print all the elements for that 10 and 50. If you want to insert again value more, press 1, and again let's suppose 105 you are inserted. Now top will become this 105. Print all the values, this 10, 55 and 50. Now you want to delete. Now if you want to insert one more value, it will give the error, the stack overflow. If you want to remove 2, 105 is removed, print the stack, देखो 105 is removed, again remove 55. Now let's print again 2 values removed. Now let's try to remove one more value, 2 press, again this 10 is removed. Now print the, let's try to print the all elements. So printing all elements, we giving the list blank, the stack is blank. Now if you try to delete one more value 2, then there is nothing to delete, then print the stack underflow. So this is the error it is giving. So this is how all the operations you can implement. Any other value, let's suppose 6, to exit, and it will exit. Okay, so this is the complete program to implementation of the stack. I think you got the idea how this stack is working. I have already explained in detail how these methods are working to insert into the value. For the temporary purpose, you can give the maximum capacity as 10, then this program will keep on pushing the values up to 10. If you try 1, let's suppose insert 10, then 2, then it will remove, that's 1, 10, 1, 20, 1, 30, 1, 40. There is no error, because capacity is now 10. 1, 50, 1, 60, 1, 70, 1, 8, up to 10 values it will insert. 1, 90, 1, 100, up to here it is no problem. Now let's try to insert. If you print all the values, it is giving the 10 values. Now if you are trying to insert one more value, let's say 102, then it will give error, stack overflow, because your stack is overflow, and if you add any other value, then it will exit. Okay, so this is how this stack is implemented. You can note down this code and run it on your editor, it will work. And thank you so much for watching, and if you like this video, please press on the like button, and if you like this video really, then share it with your friends so that they can also get benefited. And thank you so much. Have a nice day. See you in the next class.